Welcome to my State Motion Control's series of example and demonstration videos. This demo focuses on configuring and running a Cool Muscle CM1T with a Schneider M241 series PLC using Modbus TCP. The CM1T is an integrated motor offering additional protocols such as EtherCAT, Ethernet IP, and TCP IP. Take a look at our other videos for example demos on these protocols. In addition to the CM1T device is the CM1T Library. This library conforms to the PLCopen motion control technical specification. Conforming to the specification simplifies deployment and use of the CM1T. As you can see in this list, multiple standard function blocks are available to administer and control a CM1T axis. This demo project implements most of these function blocks and can be downloaded. Let's open Machine Expert and start a new project. The PLC we are connecting to in this demo is a TM241CEC 24T. We are leaving the controller name as my controller and using structured text in our main function. Give a name to the project and click OK. First, let's install the Industrial Ethernet Manager. Click the green plus on the Ethernet device and add in the Industrial Ethernet Manager under Protocol Managers. Once the manager is installed, select it and you will see a new set of options in the Add Device window. We will add the CM1T as a generic Modbus TCP slave. Select this option and click Add Device. Next, let's install the CM1T library. Select the Tools Tree tab and double-click the Library Manager. Click Library Repository and then the Install button on the pop-up window. Find and install the CM1T compiled library. Next, we will set up the CM1T Modbus slave. Go to the Modbus slave device and select it. On the Configuration tab, enter the IP address of the CM1T. Once this is done, move over to the Modbus TCP Channel Configuration tab. This is where we want to set up what data we want to send and receive between the CM1T and the PLC. Click Add Channel on the bottom. The CM1T will work at the fastest rate of 5 milliseconds, though in this instance I'm leaving it at 20 milliseconds, the default. We'll be reading and writing multiple registers, so select function code 23. The read offset is 1100 and a length of 18. The write offset is 1200 with a length of 14. Going over to the global variable list in the applications tree, we add in the CM1T axis reference variable. I'm creating a variable called CM1T axis of type axisref from the installed CM1T library. Oh, I just realized we installed the library to the repository but didn't add it to the project. Go back to the tools tree, click Add Library, and you'll see the CM1T under Miscellaneous. Now you see the CM1T axisref is found within the installed libraries. The next step is to map the Modbus data to the CM1T axis variable. Go to the CM1T Modbus slave and select the Modbus TCP slave I/O mapping tab. We have made it convenient by adding a list of Word objects to both data in and data out. Expand the inputs and double-click the first entry. Browse to the CM1T axis variable created and find the data in word structure. Set the first entry to W1. I'm going to fast forward a bit here as I copy, paste, and edit the names in the mapping. Do the same with the outputs and map them to the words in the CM1T data out structure. Move back to the device tree and let's do some final setup on the Ethernet device. We need to enter the IP address. I was able to see what this was from the communication settings under my controller. Once this is all added, we can log in, download the project, and see the Modbus TCP connection to the CM1T. Going to the data in objects, on the CM1T axis, we can see the motor counter incrementing, verifying our connection. Now that everything is set up, we went ahead and added some content to demonstrate the library functions. In the main PLC function, we have function blocks such as MC power and MC reset, calls to get mode information like position, velocity, torque, and status. Below these are the motion function blocks: stop, halt, move absolute, move relative, move additive, and move velocity. Towards the end, the homing functions, home and set position, assist with setting the motor's index. The final call in the main routine is a MultiMove Program. This uses a continuous function chart to run the motor between two positions. As can be seen, very little additional logic is required, as when the move absolute completes, it executes the next one. Let's log in and run the program. Some visualizations were added to help us run and monitor the motor. In the first tab, we can set some targets and execute the different types of motion. An overall view shows us all the motor information and includes buttons to power, reset, and stop the motor. In the video, you can see the position, speed, torque, and axis state changing as we execute and run the different move functions. The second tab starts a home routine. The motor is set up to home to a hard stop, so you can see when we physically stop the motor, it sets its current position to 0, which is now the new home position. Finally, the third tab runs the continuous function chart we set up to continuously run the motor between two positions. The continuous update input has been set to true, so we can dynamically change the target position, speed, and acceleration during operation to immediately update the motion. We hope you have found this video useful. Please contact MyStat support for any questions regarding the CM1T or any other motor in the Cool Muscle lineup.